Part 2 of Lesson 4 for Exercise 9C, we'll be looking at outliers and what outliers are, why are they considered important, how do we work out an outlier. That's going to be covered within this videos. Before we get to the formulas, which you can see here, I'm going to talk about why outliers are important to extract, and also the importance of the IQR, which we worked out in the previous video in part 1. So let's say we did a survey, it's survey time. Now, I would usually do this survey in class, but considering worldly circumstances, we can't do that. So let's just assume I go into a random Year 10 class. And survey question is, what is your age? And I ask every single person within that classroom what their age is. And this is the data that we get, ranked from smallest to largest. So we have you can see some commonality here, can't we? What, a 31-year-old person? A student? God, how many times did they stay down in Year 10? No, I'm totally joking. So what's going on here? We've got, let's first see how many data points we have. We've got our n value. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We've got 13 people here. We have got 12 students and 1 teacher. Because the question within this Year 10 class was, what is the ages of everybody within that classroom? I didn't say specifically students, I said everybody within that classroom. Hopefully that's the case. Maybe you can rewind and backtrack and double check, but I'm pretty sure I said everyone within that classroom. And we have this 31-year-old here. Now, it's obvious to us that that 31 doesn't seem to be within the vicinity of this data here. Kind of spanner in the works. So let's just work out a 5-number summary system. There we go. We've got a minimum, which is 14. We've got a maximum, which is 31. We've got our Q2, which is also our median. We've got an odd amount, so we're just going to take one middle value. So it's the 7th one. 1, 2, 3, 4, 5, 6, 7. How I knew it was straight away the 7th one. What I did was I took 1 away from 13, which is 12, and I divided 12 by 2 to give me 6. That meant that there was going to be 6 on one side and 6 on the other side. So the 7th position had to be the Q2, or our median. And this case here, our median is 15. Let's have a look at our 1, 2, 3, 4, 5, 6. We've got 6 as an even, so we're going to have 6 on the other side. Our Q1, what's in between 15 and 15? 15. Our Q3, 1, 2, 3, 4, 5, 6, 15 and 16. So our Q3 is 15.5. So there's our 5-number system, and the 5-number summary system. Oh my goodness, that's tongue twister. I can't talk right now. Tongue twister. There we go. I can't even say tongue twister right. So we've got a 5-number summary system. There we go. And what I'm going to do is I'm going to extract 2 things. I'm going to find the range, and I'm going to find the IQR. So the range in this case is 31 take away 14. So it's the difference between the highest and the smallest amount. And in this case here, we've got 17 as our range. Our IQR is equal to Q3 take away Q1, so 15.5 take away 15, which is 0.5. What a difference between the range and the IQR, the interquartile range. And this is the reason why we use the IQ range, because the range, the overall range is 17. That just means that the ages within the data set ranges 17 years. But that seems a bit far-fetched considering that almost 99% of the data lies between 14 to 16. So this range here, while valuable and useful, is not really a true depiction of the range of all the students within this class. This here is definitely an outlier. It's definitely an outlier. We can visibly see this. So to compensate for that, let's have a look at the IQR, the middle range. That's 0.5 or half a year. This seems to be more of a true depiction of the middle 50% of the class. This is a better depiction to say that, yeah, it's safe to say about 50%. The age range is 6 months or half a year. This is why we use the IQR. It just has some form of safety within the number in itself. Don't get me wrong, the 17 is still valuable to know, but because this is an outlier, it kind of becomes redundant information. Because I want to know about the majority and I don't want this to have an effect. So let's work out the IQR. So how do we work out outliers? How do we work outliers out? So an outlier, as we saw before, are data elements outside the vicinity of the rest of the data. More formally, a data point is an outlier when it is below what's called a lower fence, i.e. a lower limit, or above the upper fence, which is also considered as the upper limit. And these two formulas will determine how we find the lower fence and the upper fence. So before we get to that, I'll just read out these two important facts. An outlier does not significantly affect the median of the set. So if we do have outliers that are in there, it doesn't necessarily affect the median. The median is still going to be the same as we saw in our previous example. And the other fact is an outlier does significantly affect the mean of a data set. That's definitely true. Because if I were to work out the average of all of these values without the 31, this would be significantly different if I do include the 31, because the 31 is almost going to skew this mean. Okay, so two very important facts to consider. But let's look at this. Lower fence and upper fence business. What does this actually mean? All right, before we get into the equations, remember that bar that I drew in the previous video in part 1 of this series, and I said, of this lesson 4, and I said, here's our min, here's our max, here's our Q2, the middle value, here's our Q1, and our Q3. So we have these data points, okay? And obviously these data points will go within here and we order it from smallest to largest. And then we say, okay, look, it's obvious for us to know that this 31 within this scenario of getting people's ages is obvious that this is an outlier. But what happens if we have data values that aren't really that obvious? It might seem like it's not an outlier, but it could be an outlier. How do we work that out? What type of formula can we use? And so statisticians have different ways of trying to figure this out. The most common way, this is a made up formula that has to do with the variability within your data set. A statistician said, hey, look, how about we try to figure out what the interquartile range is, okay? Let's find this number, let's find this range. And we know how to find this range. It's Q3, take away Q1. All right, it's Q3, take away Q1. And then what we do with this number is we multiply it by 1.5. Or in other words, we make this number amount bigger by 1.5. Or in other words, this range here, okay, we're going to take this and we're just going to enlarge it by 1.5. So we'll make it look like as though it is now that big, okay? So it's just hypothetical, okay? They've just taken this interquartile range. Picture them, they just take it out and they multiply by 1.5. They make it 1.5 times bigger. So one lot and then another half lot of it here, okay? We don't know what this IQR number is. Obviously it's gonna be some number, but visually this is what they're doing. They're gonna take this, they're gonna take it out, and then they say, okay, we've got this size. We're gonna take this actual length here, and what we're going to do is we're going to do Q1 take away this length. Q1 take away this length, and we're going to take Q3 and add this length. All right, let's get technical now. Let's get a different color. Let's get green. We'll go green. Okay, I'm going to make this new length that I've got, and 1.5 was just not a random number. There was a lot of mathematics to get this number. Yeah, a lot of students ask, why 1.5? Where does this come from? There is mathematics behind it, but I'm not going to get to it. It does have to do with what's called standard deviation if you want to YouTube this. But let's just take 1.5, okay? And I'm going to take this. I'm literally going to pick this up, and I'm going to put one of them here. And I'm going to put another one here. I'm just going to kind of intersect this equation here. Okay, so I've taken this chunk, this range, which is 1.5 times that middle range, and I've plopped it here and I've plopped it on the side there. And then they say, all right, where that part starts, this is what's called a lower fence. Okay, this is what's called a lower fence. And up here, this is what's called an upper fence. Now you've got to remember, when we work this out, this is visually what's going on. The lower fence is just a number. It's going to be a number, okay, when we work this out. And the upper fence is also, again, just a number. And when we work out these numbers, we then have what's called a fences. Anything lower than this fence and anything higher than this fence are considered outliers. Now I know this is a lot of explanation without some real example or real context within here. Kind of seems arbitrary or made up. I've just kind of found out what this length is, made it longer, plopped it on two sides and said, hey, anything lower than this and higher than this, outliers. A lot of maths and a lot of research went into this as a best representation. There are other ways, but it's a good starting point to try to find out outliers, okay? So you've got to remember, within here there will be data points, there will be numbers. You will find an RQR, which is a range. When you enlarge it and plonk it this way to Q1, you will find a number, and you will find a number. Anything lower and higher than those fences are considered outliers. So imagine the previous example. If I got those 14s and 16s and the 31 and I plonked in here, and then I found my middle range, which I already did, which is my IQR, and I said 0.5, and I got that 0.5 range and I enlarged it by 1.5. I plunked it where Q1 is, before Q1, and I plunked it after Q3, and I said, okay, let's work out these numbers. Anything lower and higher than those numbers will be considered outliers. I'm going to do an example for you to show you what's going on and how this works, Probably would be a 20-minute video. I'm looking at it's 15 minutes now. But I really want you guys to get the grasp of this, especially for those who are doing general maths next year. You will definitely be seeing this. If you're doing VCal maths as well, you will see this within the data range, and you will be talking about what an outlier is. So it's still good insight regardless of what maths you're going to be doing next year, okay? Let's have a look at this example. All right, we have got an example right here, which was taken straight from the textbook. I'm just putting another layer here. Here we go. Okay, so this example here, the following data set represents the number of flying geese spotted on each day of a 13-day tour of England. Now, before we continue, I found out a fun fact that the baby version of geese or goose is called a gosling. I don't know if you guys knew that. So Ryan Baby Goose, apparently that's his name. I want to put a picture up of Ryan Baby Goose just because I can, because of software editing. I love this program. There he is there. Okay, that's enough distraction for now. The following data set represents the number of flying geese spotted on each day, 13-day tour of England. Those are the number of geese they saw, 13-day tour. So there should be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yes, so 13 data sets. So our end value is 13. For the data, we're going to find the minimum and the maximum number of geese spotted, the median, also known as Q2, the upper and lower quartiles, so whoops, that is Q1 and Q3, the IQR, which is Q3 take Q1, and any outliers by determining the lower and upper fences. Now we can see that it's pretty obvious, maybe to some people anyways, that this 18 here seems to be pretty far out from the actual range of numbers here. It's a double-digit number, and not only that, it's quite close to 20. The one before that is a 7, so there's a massive difference. But we're going to look at the maths behind it just to prove mathematically that 18 is an outlier. For now, AI, the minimum and maximum value of the geese spotted. I'm not really going to do I. I'm going to put these numbers from smallest to largest first, because that's going to help us determine the other questions. Obviously we can tell what the minimum and maximum is, but I want to put this in order from smallest to largest. How I do this is I look for the smallest number, which is 1, and then I cross it off. And I keep doing this until all digits are done. I'll pause the video and I'll come back to it. Oakley dokleys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Luckily I did this while this was paused because I did make a boo-boo. I forgot that last 4 there. Good to double check that you have your end value correct. In this case it was 13. And we are going to now find the minimum and the maximum. Easy. Easy peasy. Min and max. Minimum 5. No. 1. I looked at the smallest, the first amount here. Oh, silly. Maximum 18. Done. Second one, median. So the median, or Q2, it's finding that middle value. There are 13 number sets, so we're just going to extract one number in the middle. 13, sorry, so 13 take away 1 is 12. 12 divided by 2 is 6, so 1, 2, 3, 4, 5, 6, 7th number. 1, 2, 3, 4, 5, 6. So our Q2 is 4. Done. Third one, we're going to be looking for Q1 and our Q3. So Q1, 1, 2, 3, 4, 5, 6, middle 2 here. 2 and 2, so it's 2. And 1, 2, 3, 4, 5, 6, middle 2, 5.5. So it's in the middle. Again, if you're having trouble, if there are two numbers here that you're trying to get. You're just finding the average of the two, so you add the two up and then divide by 2. It's easier when the numbers are close to each other or exactly the same, because it's just in between that or what the number is. Next, we're going to be finding the IQR. I'm surprised I didn't ask for the range in this example, but that's okay. Our range in this case is 17 because it's a maximum takeaway minimum. For the IQR, this is going to be equal to Q3, which is 5.5, takeaway 2, which is 3.5 as our IQR. Now this IQR is going to hold an important role to determine if there are any outliers from a lower and upper fence. So this is the tricky part where we're using the lower fence and upper fence formula. So lower fence I'm just going to call LF for short. You got to remember our lower fence is Q1 taking away 1.5 lots of what the IQR is. So Q1 take away 1.5 times IQR. So let's work this out. Our Q1 is 2. And we also want to work out, I'm going to put these in brackets to indicate that it should be worked out first. We're going to find out what 1.5 times the IQR is. It was 3.5. So 2 minus 1.5 lots of 3.5, and this ends up being 5.25. So we're working out 2 minus 5.25, and this ends up being negative 3.25. What does this lower fence mean? So what we've worked out is we've gone from 2 and we've backtracked. We've taken 1.5 lots of what the IQR is, 3.5, and we just attached it to the side. And then where it started, or where it stops, depending on your perspective, anything lower than that is considered an outlier. Negative 3.25. Is there anything lower than negative 3.25? Well, not really. You can't have a negative amount of geese. And the fact that it's negative, don't be startled by this, okay? We're just playing it safe to say, hey, we've gone way, kind of a bit further out. Just to play it safe, anything lower than this is considered an outlier. So, nothing lower than lower fence. Nothing lower than a lower fence. Alright. Let's find the upper fence and let's prove that 18, let's prove that this 18, I'm going to start it here. Let's prove that this 18 is an outlier. So again, we're going to do the upper fence formula. Just remember that it is a plus because we're adding to the Q3. So we're going to the right hand side. So Q3 in this case is 5.5, which is up here, plus, now we already know what 1.5 times the IQR is because we worked it out here. So it's 5.5 plus 5.25, which we've got here. And 5.5 plus 5.25 is 10.75. So this is our upper fence. This means anything that's considered higher than 10.75 is considered an outlier. And of course, 18 is considered higher than 10.75. So we would say 18 is an outlier as it is higher than upper fence. Okay, so admittedly there is quite a bit of maths to prove that this 18 is considered an outlier. we have to work these out. And it's not that tricky. It is not that tricky, because all you do is you start with your data set, find your Q1 and your Q3, and just plug it into the formula. These lower fence and upper fence formulas, they don't change. The numbers do for Q1 and IQR, but everything else remains the same. And we're just using these numbers, these fences, they are guides, okay? They have no other significance other than knowing if anything is lower or higher than that. They don't serve any purpose, they're not a data point, they're just hypothetical fences that statisticians have made up by using this formula to determine the best way to finding out outliers. Long video, but a lot of information to take as well. I apologize, but this will definitely help you with the questions that you have. The log sheet shows measures of spread exercise 9C from the textbook, or page 678. Go ahead and pick your strand to see what you're capable of, and I will see you guys in the next video. See you, bye bye.